Hi friends, so I wanted to talk through number 1 on worksheet 4 so that you get a model of how to solve for these problems, just to make sure that using that FBD that we discovered yesterday, that you can solve these conical pendulum problems. So step 1 is that you are going to want to draw an FBD for this rubber stopper. So it's whirled in this conical pendulum, and I want to make sure that when I draw any FBD in any circular motion, I want to make sure that it is drawn on my circular path, because I need to know where the center of the circle is. So I know what the F net radially inward is. So I know I'm going to have some sort of force that points radially inward here. And I know there's going to be a force of gravity on my FBD. And I also know my force of tension is going to be along the string. So when I look at this diagram like this, I can tell that this is going to be FTX. This will be FTY. My FTY and my FG are going to be equivalent because I'm not accelerating in this direction or this direction. I'm only accelerating radially inward. So I want to determine this angle. That's my goal, and I can tell that it's there because of my diagram. So I drew an FBD for the string. What force causes the centripetal acceleration? FTX. All right, so I first need to calculate the period. And I'm given the mass in grams. So I need to make sure that that's in kilograms. So 123.015 kilograms. The radius of the circle is 50 centimeters. Man, we got to convert all these values. 12.5 meters. And then the speed is 4 meters per second. So I have mass, speed, and radius. And I want to calculate the period. So for part B, I'm actually going to use this equation because this equation has my period in it. So I'm going to use my 4 meters per second, my 2 pi times 0.5, and then there I can calculate that period. So you can do that. Now part C, I'm trying to calculate the angle. So in order to calculate the angle, right now, in my vector triangle, I don't know any of these sides. So I'm going to need to calculate one of these sides of my triangle to be able to get theta. I'm going to need to calculate two sides to be able to get theta. So when I look right here, I remember FTY is equal to FG. So I can calculate FTY. So my mass is 0.015 kilograms times 9.8, and so you can calculate that. So I have this side. I know that side. But I need another side. Can I calculate FT? Can I calculate FTX? Oh, I can calculate FTX because FTX is my F net equation. I know my velocity. I know my mass. And I know the radius of my circle. And so by doing that, I will be able to calculate FTX. And so that will go right here. And then, once I know ftx and fty, I can solve for theta a couple different ways. I could use tan of theta, which would be mg over that ftx, so fty over ftx, and I could solve for tan theta that way by taking the inverse tangent. Or, because I need to calculate the force of tension in the string anyway, I can use Pythagorean theorem. So just to remind you, Pythagorean theorem is that a squared plus b squared equals c squared, where a and b are sides of the triangle, and c is the hypotenuse. So I could use ftx squared plus fty squared would give me ft squared. So I could do part D before I actually calculate the angle, and then I could use sine, cosine, whatever I wanted to calculate theta. If you have all three sides of the triangle, you can use any trig identity that you want. All right. Then I do want to go over one more time an FBD. So let's do let's do the pig. So here we're going to draw in our circle. We've got our FT. We've got our FG. These are our components. And we know that FG will be equal to FTY. Because it's not accelerating vertically. And this one, we're also actually not given an angle. We're not given an angle. But we are given some other information. So we're given mass. We want to always write that down. We always want to write down that FTY is equal to FG. So we are given the mass, we're given the velocity, and we are given FT in the string. So we're not given FT, we're not given FTX, so we can't just plug that in for our net force. We're given the actual force of tension. So that's a little bit more complicated. So we have to get a little bit creative with this. We can solve for FTY. So I'm just going to start to solve for FTY because basically to solve for this radius, I'm going to need to calculate FTX. So I can solve for FTY because I know the mass. And once I know FTY, so you can solve for that. But once I know FT, and I know FTY, I can figure out what FTX is. I can figure that out because I have two sides of this triangle. So basically, I'm going to use this Pythagorean theorem again. C is my hypotenuse, so it's that force of tension. FTY is one of my sides, and then I'm going to solve for FTX using Pythagorean theorem. So you'll notice Pythagorean theorem can be really useful in this worksheet. Okay, so now it's your job to do number 2 and number 3, to try those two on your own and to check the key and correct your work. Let me know if you have any questions, and you can always sign up to meet with me via Calendly. Bye, friends.